Some days ago, Jeranism held his first live. I will have a shorter look on that one today. The first guests on Jeranism's new live debate was MCToon and Biran's Leake. Biran thinks he won this debate and also did some other flurfs. I normally don't look at live debates, but this one was really funny. Let's start. Before we have a look at the part of the debate, I want to show two videos that are reactions to this debate. The first one is from Flatsoid. He have titled his short video, MCToon, welcome to Flat Earth Matt.
Michael, so my first question is here just north of where they launched, you know, in Jacksonville, Florida, they some people, you know, I've actually tricked some people and pointed, since I learned perspective, I pointed to the horizon, you know, when on a clear day when you could see an airplane fairly close to the horizon, and said, look at this space shuttle, check it out. And they was like, no kidding, man, you know, it literally looks like a space shuttle on a clear day where you could see that far going straight up for a couple minutes. I'd like to ask, how do you explain that in your model? Why does the airplane look like a space shuttle in the distance going straight up in the air? And then when it gets overhead, it gets straight. And then as it sets on the other horizon, it looks like something going directly straight down. How do you explain our local, you know, sphere of vision, for lack of a better word?
Well, it's not a sphere of vision, but how do I explain that? That is simple perspective. Every single part of the path that plane is taking can be explained easily with just solving triangles. Can be explained easily with just solving triangles. Easily with just solving triangles. With just solving triangles. If you don't need to know anymore the actual process of doing it. There are online calculators for it. So when an airplane is, say, you know, I don't know how far away you can actually see an airplane, but let's say it's 20 miles, right? So when an airplane is 20 miles away from you and it's 6 miles up, right? Then you can solve a triangle and you're going to say that is a very low angle, very small angle to the ground. When it's closer, say it's 10 miles away, that angle is going to be higher. When it's directly above you, well, of course, it's going to be straight up. And then as it passes over you, it's going to reverse that same line of that it did on the way there. And so that angle is going to progressively get smaller. So it is a simple application of a perspective, solving triangles. That angle is going to be higher. When it's directly above you, well, of course, it's going to be straight up. And then as it passes over you, it's going to reverse that same line of that it did on the way there. And so that angle is going to progressively get smaller. So it is a simple application of a perspective, solving triangles.
And as usual, flatsoid is dishonest. He thinks this is connected to his stupid arguments about triangles and astronomical navigation. Typical flatsoid. The next one is a video from Biran where he thinks he won the debate, and it's titled "This is how you expose MCToon's lies."
Sun should be shining this way. Problem is, the sun is now way down here.
So if you raise up the moon half a degree, you would raise it up 2,000 miles, which is not, I mean, it kind of would help. But the sun, if you raise it up half a degree, you'd raise it up 800,000 miles. So
let me break this down. This is the excuse Toon uses for the top of the moon being lit when it's high in the sky from a sun sitting 1 degree above the horizon. Okay, because the moon, remember, can only be 240,000 miles above us at its maximum. So they show us this trigonometry where a sun 1 degree above the horizon is actually 1.6 million miles above our feet and like 1.4 million miles above the moon. So, but then they'll simultaneously try and use it as a proof with the sun sitting barely above the horizon, shining up on the bottom of clouds or casting shadows on the bottom of clouds. So you can't have both. You can't have a sun sitting above the horizon, shining downward on the moon and upward on clouds. This kills parallel sun rays, which in turn kills the globe model.
It was thrown at me that the sun putting a shadow up on the bottom of clouds or lighting up the bottom of clouds was some kind of proof for a globe, when in my earlier I showed how it works just with atmospheric lensing. But if we're going to use the trigonometry, if a sun is 1 degree above the horizon, that means it's 1,600,000 feet approximately. I mean, 1,600,000 miles above the tangent of my feet toward the horizon. So it's way above the clouds. So if a sun, I've showed several, but I've showed the sun up to like 4 or 5 degrees, still lighting up the bottom of clouds. Now, how can a sun that's millions of miles above that cloud be casting light on the bottom of that cloud?
So I example a sun 1 degree above the horizon, and after I show him the trig, he calls it a negative angle. That's called a bold-faced lie.
How's that possible?
Because it's not millions of miles above that cloud. That's easy.
Okay. So you disagree with the trig that a sun 1 degree above the horizon, okay, 93 million miles away, puts the opposite side at 1,600,000 miles? You disagree with the simple trig?
You did not show any trig, so I'm not going to agree or disagree to any trig that you're referencing.
So he can't address this, folks. They can't, and they won't. So he just says, well, you ain't showed any trig. So then I pull the trig, and then he just starts describing something underneath the tangent, like something I'm not even demonstrating. It's like talking to a donkey.
I've not seen it to agree or disagree with it.
All right, I could pull it real quick. I thought we were going to keep this honest.
So you're showing the trig right now for your distance above the tangent? Okay, I'll send it to Tim. For distance above the tangent.
So Jaron just looked at it. He understood it. Angle above the tangent. Why didn't Toon understand it? So I must have asked him 5 times, describing a sun 1 degree above the horizon, and he calls a sun 1 degree above the horizon a negative tangent. That's all he could do, because he knows where it's heading. That, my friends, is blatant lies.
Okay, so if I go up above the clouds,
the sun is below the clouds in this instant of when you're talking about the tangent there. The sun is below the clouds.
So if I go up above the clouds, then the sun's going to follow me up, right? So if I go up 1,000 miles, the sun's still going to be at a tangent to my feet, right? It's still going to be 1 degree above the tangent of my feet, right? Way above the clouds, right?
It was never above your tangent. It was always below your tangent. It was never above your tangent. It was always below your tangent.
So no matter how crystal clear I describe a sun 1 degree above the horizon, he keeps calling it below the tangent. That's how you expose a liar.
I'm on the moon and I have the same exact angle damn near as I had on the ground. A 1 degree shadow casted. I put a 1 meter stick in the ground. I've got about a 28 meter long shadow casted down 1 degree. If I go up 20 miles above the clouds, I've still got a downward 1 degree shadow, right? If I go up 1,000 miles, I've still got a downward 1 degree shadow. And you're disagreeing with the freaking triangle calculator?
It was never above your tangent. It was always below your tangent.
There you have it, folks. Clinic number 1 on exposing MCToon's lies. More to come. And so what they have, folks, is a mathematical model. So I'm attacking it within the model with the mathematics. So for the flat earthers who don't want to take the time to understand the math, I understand that. But look at him squirm. You don't have to understand the math to watch him squirm and weasel his way out of answering the questions, because this one they cannot answer.
I think this is dishonest. Brian have taken parts of the debate and then added comments and so on that MCToon can't respond to, and his audience can't hear the whole debate in the subject. So I have chosen to show you MCToon's first topic and how Brian's react to that one and reply to that one. Let's start. I must warn you, this will be a real dumpster fire.
Ryan, blink twice if you're okay.
I can't hear you though.
They said somebody said that you look like you're in a hostage video. And
what?
Gail Carlos says blink twice if you are being held hostage.
As you all understood, that was not MCToon's first topic, but I had to add this one too. It was hilarious. Let's listen to Toon's first topic.
Let me bring on the guys. Toon against Brian Leake. The shape of the Earth is the topic. Let's go ahead and bring them on.
My question. What is the bottom-up obstruction prediction formula for flat Earth?
Non-existent? No, I'm just kidding. You know, I'm gonna say, well, there's a couple ways really to do this, man. The first way we do is get the distance to the horizon. So I think what Toon's looking for, and I'm gonna, like I said, I'm gonna try and keep this as honest as possible, is that 8 inches per mile squared is the you know, the measurement of the Earth, but has nothing to do with the hidden obstruction. So I'm gonna try and keep it real, and what he's looking for is the formula. So, you know, you have to start with the distance of the horizon, which is one way to do it is 1.22 times the square root of the observer's height in feet, and then you take that and then you apply. Let me see, I wrote it down. So x would equal a squared minus 2ad, where a is the obstructed height, and d is the distance to the object, plus d squared plus r squared minus r. So basically, but you could also do it, you know, I've seen a couple things where you could do r plus h, where r is the radius, and I actually tried this, and it does actually work. It didn't look like it worked, but r plus h, which is the radius plus the viewer height squared minus the radius of Earth squared in feet, and all that square rooted. It actually does work if you do these numbers, but you know, the real way that most people would do it too was I would say it'd be g over o to the OGL times E. That's the way most people do it. Where G equals Google, and then the OO equals Earth Curve Calculator, and then the LE, of course, is type in your height and your distance, man. So that's how most people do it. I'm just joking, man.
Okay, your question, Brian. Go ahead.
All right, so number two is.
All right, hold on, Jaron. Write this down for next time. You need to give one like quick answer back.
Okay, we can do that.
Next one, yeah.
We'll do that. Do you want to give your answer? Well, we'll do it next time. Go ahead.
Yeah, absolutely.
I just say all that was based on the globe. Okay, go ahead, Brian.
No, go ahead and respond to that. Was that what you was looking for, though? Like the 8 inches per mile squared?
I was looking for the flat Earth formula, not for the globe formula. You gave me the globe formula.
Oh shit! If you want a flat Earth formula,
yes, that was the question. It included 4 flat Earth in the question.
For flat Earth.
Brian, you goofball! You goofball!
Bro, it didn't say nothing about flat Earth because I've already gave you my formula. It's 90 minus A over 90 times D times point A times 100 of A minus 1/2 A, where D is the triangulated distance to the sun or star, whatever you're measuring.
This is the bottom-up obstruction.
Yeah,
when something is 40 miles away, how much will be obstructed? Oh my gosh!
Ask your question, Brian. Go to the next one.
I'll tell you what. I put in a 30-second video to explain this, bro. I thought we were gonna be honest. You're a veteran. I consider you a veteran, but if I got to re-show you this, I got a 30-second video for anybody who doesn't understand how the sun sets on a flat Earth.
I didn't ask how the sun sets.
No, we're not gonna. We're gonna go to the next. No. You ask your question now. We'll pass that one. Brian, you're up.
Well, you interrupted me during my formula, so I'm just saying. He's what exactly are you asking for, man? You don't want my formula.
He was looking for the bottom-up obstruction equation for a flat Earth, but let's move on to the next one. This is what I didn't want to do: is get stuck on something. He didn't. That's fine. We didn't get an answer for that. Doesn't matter.
What does he think? Wait. What does he think I was giving him? Just like
You gave me the globe formula.
No, I didn't give you the globe formula. 90 minus A over 90 times D times point A times 1/2 A is not the globe formula, bud.
What's that formula do?
I'm sure that's a refraction formula. Like I said, every flat earther might not agree with this, but this is just a pretty much a distance formula, and then from there you figure the obstruction.
Okay, we can do this in the topics if you want, but move on to your next question, Brian. Please, thank you.
Okay. Yeah, I'm not trying to not answer questions, just so y'all know.
Gotcha.
So, hold on a second, man. 1 second.
Yep. What are we on? His second one?
Yes.
Did I say 90 minutes? I meant 190 minutes.
You gotta love Brian. He's always Brian. He's always the same. You gotta love him.
All right, we'll get to the question here eventually.
He's like, oh, just a second. And then he walks away.
Yeah, man. I'm sorry, man.
It's okay. We're ready.
Sorry.
It's so good.
Okay, number 2, man.
Yes.
Number 2 is, let's see.
So this was one of the subjects, the complete recording from the live. So now you can make up your own mind. On this topic, who's the winner? In the descriptions you will find a link to this debate, so you can listen to all topics discussed. It's over 2 hours long. The plan was that it should be 90 minutes, but do you have a debate with Brian Leake? It takes time. According to me, the whole debate was a big dumpster fire. Brian didn't come up with any real evidence. He was so confused, so sometimes I couldn't follow his logic or lack of logic. Did like this one. I think it was a great way to expose how little those flat earth fools understand about anything regarding science. Thank you for watching my videos and supporting my channel. Your support helps me help Ukraine with things. One of the most common thing I buy and send to them are drones. Thank you very much. This was a shorter video, but I think it was quite funny. I hope you liked it. I will be back soon. Have a nice day. Bye.